Here we are, 2.5 literal equations. Literal equations might not mean a whole lot to you, but it's also known as rearranging formulas. You guys know what formulas are, and what we're going to do is rearrange them to get a particular variable by itself. Okay, so example 1, solve each equation for x. So just a normal equation, one variable, we want to get x by itself. So we use our reverse order of operations. So we're adding 6 on both sides. 2x equals 16. Divide both sides by 2, and x equals 8. Okay, so that's what we did in previous sections. That's what you've done in middle school. It should be totally good to go with that. Example 2 looks a little different. This is a formula. It is an equation made up with only variables and operations. There are no numbers in it. You still want to get the variable x by itself. Well, you're still going to use the same type of rules. So we would want to add b. These cancel. We have ax equals, well, b and c are not like terms, so I'm just going to write b plus c. I also could have written c plus b. Doesn't matter. And then again, I want to get x by itself, so I'm going to divide. Whenever you multiply or divide, you have to do it by everything. So the whole right side, b plus c, gets divided by a. Your a's cancel here, and look at this. We now have x by itself. You cannot simplify the right side at all, so we just leave it like that. Is there any difference in how we solve these two problems? Well, sure, there's different numbers versus the letters, but if you look at the steps, they're the exact same. We added 6 here, we added b here. They were in the same spot, we added them on both sides. We were left with this 2x term. Here you were left with the ax. We divided 2, we divided by a. And you got your solution. If anything, this one's actually maybe a little simpler because you didn't have to simplify anything. You didn't actually have to do any arithmetic. Over here we had to do 10 plus 6, figure out that's 16, then divide by 2, figure out that's 8. Now that's not hard arithmetic, but over here we didn't even have to do that. We just added b and c and divided by a, and that's all you can do. Okay, so these rearranging formula problems, these literal equations, you're going to do them the same way you would solve a regular equation. Okay, so we have that same equation as in example 2, but now we want to solve it for a. Okay, remember, variables are just placeholders for numbers. Variables are numbers, we just don't know what number they are, so they're just placeholders. They're just holding the place for some number that we don't know yet. Because they are just placeholders for numbers, we can solve them the exact same way we solved regular equations. So what I would suggest you do is circle the one you want to solve for, which would be a, or if you have a highlighter or you want to write it in a different color, something that you're showing that that's what you are trying to solve for, so that your eye and your brain remembers that that's what you're trying to get by itself. And then it's just a matter of stripping off all of the other variables, all of the other numbers, all of the operations besides the a. So at the very end, we want it to say a equals something. Okay? So you have choices. Should we divide by x? Should we add b? Well, I think we should get rid of the b first because that's the opposite order of operations. Or you can think of it as what's further away, what's easiest to strip off. To get rid of the minus b, you would add the b. Those cancel. Ax equals, again, you can write c plus b or b plus c. I like to keep it in alphabetical order, but there would be nothing wrong with c plus b because we know commutative property says that we can change the order we add in and it'd be totally fine. And then we want to get the a by itself. Well, you have a times x. The opposite of times is divide. And you want to divide by what you are trying to remove. What are you trying to get away from the variable? Well, we want to get a by itself, so we're trying to remove the x. Divide by x on both sides. So these cancel. We get a equals And none of that can be simplified, so it's just b plus c over x. And sure enough, we got it to say a equals some stuff. Okay. Hot tip. Last hot tip, some of you guys didn't remember. Remember this hot tip. When you are solving equations, you are undoing them. So you're performing the order of operations, PEMDAS or GEMDAS or GEMDAS, whatever you want to call it, backwards. Okay? Example 4, we have the formula for the area of a triangle. Remember, that is 1/2 base times height. We want to get the b base by itself. Well, it's being multiplied by 1/2 and by h. You can choose which one to get rid of first. Really wouldn't matter. I would like to choose the number because maybe that's what we're more familiar with is removing numbers. So to get rid of multiplication by 1/2, you have options. You can divide by 1/2. A divided by 1/2. Well, now I have this big messy fraction. That's no good. So a better option, you could work through this, but a better option from the beginning, instead of dividing by 1/2, you can multiply by the reciprocal of the fraction. And the reciprocal would just be the flipped over version of it. Well, that's just 2, or 2 over 1. So my left side would give me 2a. That's a whole lot easier to figure out than a divided by 1 divided by 2. And 1/2 times 2 over 1, well, that'd just be 1. So we've eliminated the number. So keep in mind, whenever you want to get rid of a fraction, you can divide by it. If you're multiplying by a fraction, you can divide by the fraction, or you can multiply by its reciprocal. Okay? Lastly, remember what we're looking for. See, I didn't highlight, I didn't circle, so I kind of forgot. I had to go back and look. So maybe circle that so you don't forget. I'm trying to get b by itself. I have b times h. The opposite of times is divide. Divide by what you are trying to get off of the variable you're solving for. I now have b all by itself, and I'm left with 2a over h. Okay, what's the point of doing this? Well, suppose you had a problem where they said the area of a triangle is 12, the height of the triangle is 4, and they say find the base. Well, the advantage is here, you could just plug your numbers right in. 2 times 12 is 24, divided by 4 is 6, and we know the b is 6. Versus if you would have plugged it into the original problem, you would have had to have solved the equation. So it's essentially solving the formula so you don't have to solve the equation. To be honest, we don't use it all that much in math because in math we know how to solve equations, so it's no big deal. But in science, they like to use it a lot. Okay, because they use a lot of those formulas and they use them repeatedly, so there's an advantage in being able to have it set equal to a certain variable if you're going to use that a lot. Okay, number 5, perimeter for a rectangle. Well, we know perimeter, hopefully we know perimeter is just adding up all of the sides. Okay, so you would be adding your length, your width, your length, your width, because you'd have 2 lengths and 2 widths. So we could say it's length plus width plus length plus width, or we could say it's 2 of the length plus width. Either way, we're going to use this one though since that's what they gave us, and we want to solve for L. Okay, I'm going to actually highlight it. So I don't cover up my parentheses. Okay, if I'm solving for L, there are options here as well. Your first thought might be to do distributive property. That is totally fine and you can do that. However, an easier way to get this problem started, you know this is multiplication by 2, you know you're trying to get this by itself, just divide by 2. Because this is 2 times this whole quantity, you are allowed to do that. These then cancel, and you get p over 2 equals L plus W. And then finally, you want to get L by itself, so we need to subtract W. We have L by itself, and we get that P over 2 minus W is equal to L. Okay. Let me show you that it would have been okay to distribute first. I'm just using this space down here. If we would have distributed that 2 first, we would have had 2L plus 2W. At that point, we would want to subtract 2W, keeping in mind we're trying to solve for L. So we get P minus 2W equals 2L. To get L by itself, you would need to divide by 2. Keep in mind you have to divide everything by 2. So this does get our L by itself, and then on this left side you would have to simplify. P over 2 is just P over 2. This would be a minus sign, and 2W divided by 2 is just W. Same answer we got over there, a different way. As long as you are following your rules, backwards order of operations, you may do it either way, get the same answer. Okay, use the following formula for interest and solve for the given variable. Oops. So the first thing they want us to do is solve for t. T is right here. So we have a equals p times 1 plus rt. And if we're trying to solve for the t, you've got to start undoing the stuff that's on the same side as it. This is very similar to the last problem in where you have the choice to distribute, but I would suggest that's not what you do. What I would suggest that you do is that you divide by the p. Since it's multiplication, we can divide on both sides to get rid of that. So we get a over p equals 1 plus rt. Then you would need to subtract 1. A over p minus 1 equals rt. And then one more step, you need to get t by itself. And you can do that by dividing by r. Now we have a lot of stuff happening on that right or on the left side. You have a fraction divided by something. That is not okay. You can't leave that. Remember how you divide fractions. If you have 1/2 divided by 4, you change it 1/2. First of all, you would make it over 1. And then you make it multiplication and flip the second fraction. So here, this is our numerator. That stays the same. But then you make it multiplication. And instead of dividing by r, you'd be multiplying by 1 over r. This becomes distributive property. A over PR, multiply the denominators, minus 1 over r equals t. Messy, but that's your answer. Okay, on the same problem, now you want to solve for p. Go ahead and pause the video and you guys do it. Okay, hopefully you didn't run into too much trouble because this is p times this whole quantity. Make it easy on yourself. Just divide by the whole quantity. When you do that, there's nothing else left. It's just the p. And then you have the same thing on the left side as you did in this step. Nothing simplifies. You can get rid of your parentheses at that point, but you can also leave them on. Nothing wrong with that. Sometimes the variable that you need to get by itself is in more than one location. Hot tip. Simplify to get the variable you want by itself on the same side, then factor it out. Let me show you what I mean by that. So you want to get the variable that you're trying to solve for, in this case x. You want to get them on the same side, everything else on the other, potentially. So I would want to add cx, and I would want to subtract b to get that over there. Maybe that's too much in one step. That's fine. Do it in 2 steps. So ax and cx are being added. We also have a plus b. D is left on the right side. Now subtract the b if you didn't want to do that all at once. So ax plus cx equals D minus B. Okay, so we have them on the same side. We have the x's on the same side. Now we want to factor it out. Normally we would just combine like terms, but you can't combine these because there's an a and a c, not numbers. What you can do is factor out the x, which is like the opposite of distributive property. So you should be able to see that this looks like you distributed an x to two things. So instead go backwards. Take the x out, and what would have been left, or what you would have multiplied it by, would be a and c. You can check it by thinking of distributive property. X times a, that's ax. X times c is cx. So that looks good. Finally, you have multiplication here. So you need to divide by a plus c. Left off my parenthesis. X equals d minus b over a plus c. Okay, on example 9, let me pause. You guys pause it and see if you can figure out what to do. Okay, you've got x's in two spots in the numerator and the denominator. Well, we don't want to have to deal with a fraction. Anytime you want to get rid of a fraction, multiply by the denominator. But whatever you do on one side, you must do to the other. These would cancel then. Totally gone. You don't have to do it in the numerator because those canceled. So we get this line. We want to get the x's on the same side, so we subtract an x, and then we have this line. At that point, you want to factor out the x, undistribute it, so an x would come out, 2g would be left from the first term, and if you take the x out here, you kind of think like, oh, well, there's nothing there, but remember, it's the opposite of distributive property. The only way you would get a minus x is if you distributed x to a minus 1. Okay, then you have x times all of that, so you have to divide by that 2g minus 1 to get x by itself and get your answer. Okay, pause the video. You guys try these two. Okay, first one. You are solving for c. I only have a single c in there. I subtract off my entire yx term, and then I divided by x to get c by itself. In the final step, you need to make sure that you are simplifying the division. This part right here, g over x, is just g over x. But in this step, you can cancel x's. When you cancel those x's, minus y is left. So make sure you are, in fact, dividing everything by x, both terms on that side. The second one, you have two x's in the problem, so you have to go ahead and factor it out. They're already on the same side together. Undistributed, or factoring it out, gives you x, and then parentheses, c plus y. Again, remember that you can check that just by doing the distributive property back out and making sure you end up with what you started with. At that point, it's x times all of that, so you need to divide in order to cancel it. And you get your final answer there.